Two more pages of LeChatelier's principle. Uh, Screaming won't help us. I guess we just have to get through it. Okay, new equilibrium system. This is not something I usually think of as an equilibrium where you're burning methane, but sure. This reaction is exothermic, so one of the things it produces is heat. And they say, what if we increase methane? If we add methane, the system will use up methane, use up oxygen, make carbon monoxide, make hydrogen, and make heat. Make sense? You go up, the system fights back by pulling down, and if it pulls down on one side, it has to push up on the other. Okay, I'm going to start doing these a little faster, and I'm going to fudge the color coding because that is taking a long time. Carbon monoxide increased means this goes up, that's our stress. The system will go down, 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 up, up. In other words, it'll shift to the left. Oxygen is decreased. If we take away oxygen, the system will want to make more oxygen, so up, up, down, down, down. In other words, the system will shift left. Hydrogen is decreased. If we take away hydrogen, the system will want to make more hydrogen, so up on the right, down on the left, we say the equilibrium will shift, or the system will shift to the right. Temperature is increased. That means we're adding heat, so heat goes up, the system consumes heat, makes more left side stuff, so the system shifts left. Pressure is decreased. Don't really care about that part. By expanding the container, that means a higher volume. What do we have here? 3 moles of gas on the left. 2 plus 4 is 6 moles of gas on the right. Heat doesn't count. It doesn't take up any space. So this system is bigger on the right, smaller on the left. If we expand the container and provide more space, the system will go to its bigger side. It'll shift right. Volume is decreased. It'll go to its smaller side. It'll shift left, the opposite of before. Traces of format. Okay. Another reaction. This is all gases, so we're probably going to get a volume question here. What happens to the system if C2H4 increases? This is ethylene, or, yeah, ethene or ethylene. If this is produced, the system will consume it, and we'll get up on the right. In other words, the equilibrium will shift to the right. If we increase ozone, the system will consume ozone and make right side stuff, so it'll shift to the right. Oxygen decreases. If we take away oxygen, the system will make more oxygen, so right side will go up, left side will go down. So we'd say the system will shift to the right. Temperature increases. That's a stress here. What does the system do? Down on the right, up on the left, or we'd say it shifts left. Expand the container. 2 plus 2 is 4 moles of gas on the left. 4 plus 1 is 5 moles of gas on the right. The system is a little bigger on the right side, so if you expand the container, the system should shift right. What if you decrease the volume? Then it goes to its smaller side, it'll shift left. Catalyst is added. Say it with me. No change to the equilibrium, you just get there faster. Good. Let's hop to the next page and knock this out. Okay, more of the same. Carbon monoxide reacts with water. Oh, this is synthesis gas, I think. And that produces carbon dioxide and hydrogen. What if we heat up the equilibrium mixture, adding heat? Right there is our stress. The system will go down on the left, up on the right. Add carbon monoxide. There we go. The system will go down on the left, use up CO, up on the right. Add hydrogen. That's our stress. The system will go down on the right to cancel this, up on the left. Remove carbon dioxide. That's our stress. The system will go up on the right, down on the left. Add a catalyst, again. Nothing. Only you get to your equilibrium point faster. And what if we increase the size of the container, as in more volume? Well, we have 1 plus 1 is 2 moles of gas there. 1 plus 1 is 2 moles of gas there. This system does not care about container volume because there isn't a bigger or a smaller side. Good. One more, hang in there. Consider the following equilibria. Okay, so there's two separate ones here. What if we lower the temperature? Okay, one of these is endothermic, the other one is exothermic. Sorry, I was pointing at the wrong one when I said that. I find it very hard to figure these out when the delta H is written like this, so I'm going to put the delta H in line with the rest of the stuff. If delta H is negative, that means the reaction is exothermic, it produces heat. I'm going to put the heat on the right. If delta RH is positive, that means the reaction is endothermic, which means heat goes on the left. Okay, now if they lower the temperature, it means our stresses look like this. What would these systems do? Reaction A wants to replace the lost heat, so it'll go up on the right, down on the left. In other words, it'll shift to the right. This one, again, wants to replace the lost heat, meaning it'll produce left side stuff. The reaction will shift to the left. As for adding nitrogen, ask these in a funny order. If we add nitrogen there and there, well, they're both on the left side. Both systems are going to see too much nitrogen, and they're both going to go down on the left to use up the nitrogen, up on the right. So both systems will shift right from the adding nitrogen. And what if we increase the pressure? Well, try not to see that part. This is the important part, reducing the container size. If the volume goes down, both of these systems will go to their smaller side. 1 plus 3 is 4 moles of gas. Here is only 2 moles of gas. This reaction will go to the right when you squish it because that's its smaller side. And this one, we have 2 moles of gas on the left, 2 moles of gas on the right. System B is volume insensitive. It doesn't have a smaller side, so it doesn't do anything when you change its container size. Good.